Hey! Hey there! Welcome to the show. It's me, JP. It's time for JP's product pick of the week. We've all arrived just in time. Thank you so much for stopping by. I'm going to pause the little video re-echo in the side there that's going to drive me mad. Mad, I say. So, what the heck is this all about? Okay, we'll talk about it. Sometimes I use the AI inside of Photoshop to make backgrounds and thumbnails, and boy, is that one weird. So, hey, what's happening here? We've got people over in our chats, so thanks for stopping by. Thanks anyone over in our YouTube chat, as well as our Discord chat. If you're wondering where the chat is, that's the place to check it out. That is at adafruit.it/Discord. And then you can look for the live broadcast chat channel right there. That one, you see that? I don't know if you can see my cursor. You can't right there. But that's it. That's the live broadcast chat channel. That's where people hang out during the live stream. So go check that out if you're wondering where people are hanging out. What else? You can see I've got a suspicious backdrop here because I'm prepping for the AdaBox unboxing tomorrow night. So come by. It'll be at 5 o'clock Pacific time, 8 o'clock East Coast time, same time as the normally Ask an Engineer Wednesday show, but this is an AdaBox unboxing takeover we're going to do. So come by for that, but I'm prepping for that, so I've got a little backdrop situation happening. What else? So I've got a cool product pick for you today, and you can go, if you want to get a jump start, head on over to that URL right there. It's the product ID 5724. You can also use your camera device to point at that QR code if you like that sort of thing. That'll take you to the product pick, and this show is being broadcast from inside, broadcast right in there in the product page. You can get it at a humongous discount, and you don't need a coupon code or anything like that. You just have to buy it during the show. It's going to be half off, and we, I think, stashed a good number of them before the show, so go check that out. I will tell you all about it in a moment and show you a little demo, but before I do, I will have Lady Ada introduce this by jumping back slightly into the past. Take it away, Lady Ada.
The can feather, which is also the code. So really, I'm cranking out these RP2040 boards with different peripherals on the right-hand side. I always wanted a board that had CAN bus built in for easy plug-and-play, no solder CAN projects. And the RP2040 feather is a great place to start that. So it's got your classic RP2040 chipset. That's a dual-core Cortex M0 ARM processor, nice chip. We pair that with 8 megabytes of QSPI flash, so you'll use that for your program or your files. That's kind of the middle top area there. You've got boot and reset buttons, so you can enter the bootloader, and the reset button, of course, you can reset whenever you want. It's got USB Type-C for data and uploading firmware and debugging. LiPo battery built in with battery charging through USB-C, so you can take this project on the go. There's a STEMMA QT port as well, and then in the the feather pinout is standard. It's got 21 GPIO pins, and 4 of them are analog, and 2 I2C ports, and 2 SPIs, and 2 UARTs. So it's got a lot of stuff going on with it. Great for use with Arduino, MicroPython, or CircuitPython. And then what I did is on the right-hand side, I stuck a MCP2515, and you're like, I've never heard of it. Yeah, it's basically a chip that has inside of it an MCP2515, which is a very, very popular CAN controller, plus a CAN transceiver. They just took those 2 chips and they squished it and they called it the 25625. But the firmware you would run on it is MCP2515. Like firmware-wise, what the code you'd run for this chip controller is like the most popular CAN controller. We've got Arduino code for it. There's CircuitPython. I think MicroPython also has code for it. Pretty much any programming language is going to have code for that CAN controller because it's the most popular one in the world. There's also a little switch capped boost converter above it that'll generate the 5 volts, so you can do CAN bus with 5 volt power because it's a 5 volt power, 5 volt logic interface. So the feather is still running at 3.3 volts, but it has the 5 volt necessary to do the CAN controlling. There is a terminator, a 120 ohm terminator, which you can disable by cutting that trace. You need at least 1 termination on your CAN bus. And then 3 terminal blocks, low, ground, and high. So now you can plug into any CAN bus which is a differential signal system. You have shared ground, which is handy, and then low and high, and then terminal screw on how many wires you want to shove in there, and they're pre-soldered, so it's a new thing. I'm trying to get more boards where you don't have to do any soldering. It's plug and play. If you'd like to use it on a breadboard, you can solder headers that comes with. I think this photo shows it. Yeah, we toss some headers in, but if you don't want to use the headers, you just want to do CAN, you're ready to go. And again, we've got Arduino and CircuitPython code. And we also have U2IF, which is a software that runs, a firmware that runs on the RP2040 and allows you to use your computer to connect to CAN devices. So like it acts as a USB to CAN bridge, which is very handy. And then of course, if you want to add sensors, so if you want to make a CAN node with sensors, we have a STEM QT port. You can plug in almost any of the many hundreds of STEM QT or Quick or PicoDev boards that come with the connector.
Yes, that's right. You can do all of that. Let me show you a little shot of it here. I had to hide some of it because I've got it all connected up to some stuff. I wanted to focus there for a second. That is it right there. And I will introduce it properly for you. This right here, that's my product pick of the week this week. It is the CAN bus RP2040 Feather. This is a Feather RP2040 with all of the usual Feather RP2040 stuff that we love. And on the end of it, it has the CAN bus controller and transceiver built in. So this is based on the very popular 2515 controller, but it also has the transceiver built into it. So it's all on one package, does everything you need. The chip name, now I'm forgetting it because it's actually, with those two things bolted together, what's your name? It is the, so it's the MCP2515, which integrates the controller and the transceiver onto there. You can see I have mine hooked up using these, peel off this paper, very convenient screw terminals that we have there to my twisted pair for the high-low differential signal as well as ground. And what you do is connect that to other CAN devices on your CAN network. So a little bit, I'll talk a little bit about CAN. Let's take a look at the product page and the Learn Guide, and then I'll show you a little bit of a demo in a second. So first of all, what is CAN? CAN, we associate it with cars. It's actually controller area network, but it is a car, an automotive thing initially. And oh, I'm getting a note that my audio is low. What the heck's going on, microphones? Let me know if that's a little better. I don't want to blast it out. Oh, I know what happened. Okay, I'm not going to mess with that thing there. Is that going to? Well, we'll see. Here, let's goose this up. How about that? Yeah, that's getting close to 0 dB. So the CAN is was originally designed as a way to cut down on the immense amounts of wiring inside a modern automobile. And I think this was in the 80s that this Bosch came up with this technology. So the idea is rather than having point-to-point sensors all heading to the front of the car where you have a central processing unit dealing with all kinds of different anti-lock braking sensors, tilt sensors, seatbelt sensors, all of these things. Build a network so that you can have a single wire that's running among many of these sensors passing the data along. You can use star topology, you can use daisy chain topology, and it just cuts down on the immense amounts of wiring. The way that the Feather RP2040 CAN bus controller works is that we have the Feather using actually onboard SPI connections to talk to the MCP transceiver and controller chip, and then that is taking all of the messages in and sending out messages, can go both directions, to any other devices, any other CAN devices on the network. Previously, I was thinking that one of the main uses for this would be car hacking, and someone asked, I think David Glaudet in our chat asked about using this for reading like from your ODB2 port. Certainly that, I believe, is possible with this. It is able to speak CAN. The thing is, it's actually useful for a whole slew of non-car and non-car hacking things because it is essentially a way to network devices that is much more electrically robust than SPI or I2C, has much longer wire runs than those. You can do, I believe it is 120 feet in a 1 megabit per second, and you can get like 1,000 meters long if you're dropping it down to like 50 kilobits per second. So depending on your needs, you can really send your data a long, long distance with great integrity. It fights noise by being a twisted pair differential, so the messages have a high and a low. That's what those two terminal positions are, other than the ground, is that when it wants to send a 0, it goes high on the high and low on the low, and then comes back down. So there's some noise, essentially cancellation going on there. You're not as worried about little voltage spikes. It also cancels out electrical interference. It doesn't send out interference because those are equal and opposite waves or differential voltage signals on them. So really, really robust. You can connect up multiple of these and have one that's kind of your main unit, but they can all talk and listen. Debodog says used in aircraft, used in a lot of robotics applications, but anytime you're thinking, hey, I kind of need a long run of a couple of, or many more than a couple of microcontrollers and sensors talking to each other, this is certainly worth considering. Let's go to the product page here for a second. You can see here it is 50% off today, so $9.98. That's, I think, the price of a regular Feather, but you're going to get it with the regular Feather RP2040, but you're going to get it with the controller and terminal block on there to do all of the CAN bus stuff. So why not? It won't interfere in any of the regular Feather stuff, but if you're thinking of picking up some Feathers, maybe get one with a CAN bus, or get a couple of them so you can talk. You can see here, if we scroll down, we've got some links with info about this. We have a link down here to the Learn Guide. So if you click on over here, this is the main Learn Guide. Liz Clark put this together. Thank you, Liz. We have pinouts for it, power management. You can talk to it in CircuitPython. You can use MicroPython. You can use Arduino. We have setup instructions and examples for using with CircuitPython and with Arduino. Here's an example here, the CAN bus test. You can also test stuff in a loopback mode, so it'll send and receive its own messages if you don't have multiple devices. It's also a lot more convenient for setup versus two CircuitPython devices plugged in at the same time and you're trying to write to them. You can do it, but it's actually kind of nice to be able to program just the one on its own. Let's see, Arduino, same sort of thing. We've got a CAN bus test that you can run in there. You can also go down to the downloads page, and here is the data sheet for the controller from Microchip, so MCP2515, which has that 2515 controller in it, as well as the transceiver. And this will give you some of the info about operating temperatures, speeds. I think the wire run distances may be also in here as well, but that's an easy one to Google. So this will tell you in great detail, it's an enormous data sheet, in great detail, everything you need to know, 90 pages long, so if you need to know it, it's probably in there. But what I thought to do is give you a little example of a couple of these talking to each other. So what I've set up, I'll go to my down view. Let's go to this. Let's go to this configuration actually. Not that. Okay. So you'll see here. This is the one I was showing before. This is a. How do I have that set up? So I can get it enough out of the way. So this is the. Set a light here. This is the Feather. I've got 3 wires coming off of it. I happen to just cut the ends off of a Cat5 cable, and I'm using some of the wires from that. It just requires 3 wires. And I've also got over Stemma QT. See, we've got the little quick Stemma QT port there. I have a rotary encoder plugged in, Stemma rotary encoder. And then this is actually a pretty long run of wire here. This is, I don't know, 20 feet or something like that. No problem. So that's running to second Feather RP2040 CAN bus controller there. I'm just going to weigh down this cable so it doesn't go flying away. And on this one, I have an OLED screen. So this will show us data coming from the first one here. So if I step back and you watch the screen there, it is receiving messages. I just have it sending the incrementing or decrementing of this rotary encoder that's built onto there. You can also see it is listing the address. So these, you give them unique addresses, so you can filter things, you can prioritize things based on which CAN device on your network is doing the talking. This is, you can see, got no problem whatsoever with incredibly long runs, and it is super robust. It's not dropping any messages there. That is one of the huge benefits of the CAN network. Let's see. What else? So here's some nice close-ups you can take a look at there. The benefit that Limor mentioned of having it essentially be solderless is that you can plug in power to it. You can plug in a battery. You can see on this one I've got a little LiPo battery. Neither of these are actually plugged into USB right now. It'll charge the LiPo from there because it's a feather. And you can plug in STEMMA QT devices over that STEMMA QT port to add sensors, knobs, displays. And you can plug in your 3 wires for the CAN bus using those terminal connectors on there. So no solder necessary. Of course, you can solder it if you have a project that needs that, but it's actually essentially plug and play. Buy it, screw some things into there, into those screw terminals, give it some power, code it over USB, and off you go. This could be many sets of wires coming into any of those ports. It'll just daisy chain along. You can set up little wiring hubs if you want to, but there's no router necessary of any kind. They are able to daisy chain or able to star configuration. The wiring, we could have plenty of wiring spliced along the length of this going out to different controllers. So really, really neat protocol. Mike P asks, this is, yeah, you could use any 3 wires. Twisted pair is what they specify for best reduction of any kind of electrical interference. I happen to be using a Cat5 cable that I cut the ends off of, but you can use 3 wires is all you need to connect those up. And an Ethernet cable is a really good choice because you probably have tons of it laying around. Does not need to be shielded, so you can get away with cheaper, lighter, easier to deal with, easier to bend wiring because the twisted pair and the differential signal takes care of any noise problems you might have. So it's much easier than if you were having to deal with using a shielded cable. Nothing fancy there, and you can of course also get away with just using 3 wires of pretty much any kind as you get to longer lengths or in more electrically noisy environments, such as inside of a car or a robot or an automobile. Then you probably do want to go with the twisted pair for the data. Other questions? Does the gauge wire have a bit of calculation for the total distance? What would you say the best size wire is? I do not know. I would Google that. I am a newcomer to CAN bus, so I really don't have any info about the best possible gauge for that. Rufus mentions you can also actually just use 2 wires, all paralleled. Yeah, I think the ground is a nice to have, but I don't think it's necessary. So I think you can just do the high-low differential. Yeah, Todd mentions you could use old phone twisted cable, POTS cable as well, since you only need 3 or 4 cables. So a couple pairs of those. Plenty of options, lots of good DIY options, given the fact that you're using either Cat5, Cat6, phone cable. Those are really good options. What else? Any other questions? Yeah, it's got those nice oval reset buttons. These cute little buttons right here that you can use as a user button once it's started, a boot button for initially getting into the bootloader. Reset button's a reset button. We've got some NeoPixels on there. I used that just to help myself distinguish between the 2 boards. One's purple, one's bluish, so I could tell which one I was doing stuff on in my code. And let's take a look actually at some code right here. Bring up my code window. And I'll plug this one into a USB-C so that we can look in the REPL there. And let's Disco tool, feather. And I will actually, yeah, that code's fine. We don't need to resave. So if I send messages by twisting this one now from wherever I want, I could go all the way across the workshop. You can see those messages coming in, which list this guy's unique address and then the integer of what my rotary encoder is doing. So looking at the code here, you can see the library is Adafruit MCP2515. So again, that's the name of the controller, even though this chip is the controller plus the transceiver bolted together. The library is still the 2515. Adafruit _ MCP2515, CAN IO, importing message and remote transmission request. And then from the 2515 library, importing 2515 as CAN. Set up here, I've got my SPI bus set up, and then I'm creating the CAN bus with CAN on SPI, told it what the chip select is. Right now, loopback and silent are false. You could turn those true if you wanted to just have messages sent by one looped back to itself during testing. And then I'm using I2C only because of this screen, this little OLED screen on here. That's not necessary for using the CAN bus. With that set up, all you do in the main loop is, with the CAN bus listener, look for messages. So the message count equals listener in waiting. If we get a message, then I'm taking that message and I'm just sort of unpacking the message into a readable format so that I could print that address and that number there. But there are some nice example code, nice code examples in the library you can check out. You can do the basic example of send and receive. You can have just a receiver, just a sender, and then a few, I believe, more advanced examples involving interrupts. It is possible to have some messages come out on top. Really important for cars. You want things like anti-lock braking to send their messages with priority over a headlight controller, for example. So you can do certain filtering and prioritization in CAN. I just haven't done that. I don't really know how that syntax looks, but those are possibilities within CAN itself. Let's see, any other questions? There's a nice link, let me bring up my Discord here, that Liz put up to a project from Colin Furs, super famous YouTuber whose name I can't remember how you pronounce. His project of some sort of vehicle contraption there is using a CAN bus to communicate among things. Yeah, I've seen projects online of CAN bus used for non-vehicle things. For example, someone who had a Hackaday project with some solar panel metering used CAN to talk between a sensor and a Raspberry Pi. So there's a lot of possibilities using this as a communication method between your devices. All right, have we done it? Do we have any other questions? I think that'll probably cover it. If I said all I have to say, I think so. So yeah, let's wrap this up. That right there is my product pick of the week this week. Are you upside down? You're right side up. That's my product pick of the week this week. In fact, let's show two of them. That makes the point, right? This is a network. Product pick of the week this week, it is the Feather RP2040 CAN bus. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. Bye.